Hi everyone. Today we are going to discuss the shaping module in Camvision. So Camvision comes with a shaping tool that is built into the core system, but we have basically more advanced shaping tools with the xShaping multiplier. So when we use the shaping module, we'll have the capability to parametrically shape assemblies, part, and operation using simple advanced constraints. So what we'll do today, we'll go over shaping assemblies, shaping parts, adding operation, and also adding constraint and also intelligence to operations and part shape and assembly shapes. So let's start first with the assembly shaping. So when we have the shaping multiplier, what we can do is to use it to create and modify the shape of an assembly in one tool. So instead of having to manually going on each single part and modifying them, we simply use the shaping from the room level and then apply a shape to an assembly. So what we'll do, we'll switch to Camvision. I have a new room and I will add a new object in my room. So for this demonstration, I'll use a tall cabinet. I'll use a tall cabinet with a pair door, add it to my room, and I'm ready to shape it. So when you want to do the shaping of an assembly, you can do it directly from your plan or elevation view at the room level. It's simply done by selecting the assembly, right-clicking on it, and on the wheel, you'll have an option called Edit Shape. And this will switch to the shape editor. When you have the shape editor, your toolbar will change and you have all the shaping tools at the top of your toolbar. So you can redraw the shape of the cabinet. You can also modify the existing shape with the modification tools, and you can add constraint as well. And the shape section is just to check the validity of the shape. So if the shape is valid, you can click on the shape button. It will be highlighted in green and it will confirm that this shape is valid. So what makes a shape valid is the fact that you have a single outline that will define the new shape of your assembly. For example, what you cannot do is having more than one outline or one closed geometry. That will basically create an error. And if you click on the check button, Camvision will show you the error message and also highlight in red where is the error coming from. So in this case, I have too many shapes, which means that I don't have a single cabinet outline in order to rebuild my assembly. So if I click OK, I can simply fix it by selecting the line and deleting it. And if I set to check again the shape, now it is valid. And it will now allow you to return and save the new shape of your assembly. So now if we want to modify the shape of this assembly and make it look like the one we have on the slide on the screen. So all I have to do is being in the elevation view, right click on my assembly, select my shape button, edit shape, and now I will be able to redo the shape. So for this one, I'll use first a line. So I will draw a line to the top corner of my cabinet. I use my trim tool. So the trim is in the modification toolbar, and you can also change the mode you want to use for the trim command. So you have a trim delete, trim keep, and trim break. So in this case, I'll use a trim delete. So with the trim delete, I will click on the lines I want to delete. So now I will be left with just a single line. And if I click on the check button, this will confirm that this is a valid shape. Before you click return and save, it's always important to check the type of the additional geometry that you're adding. So for example, if I'm adding an extra line on my shape, I want to select it and I look at the left of my screen, and this will be to select the type, the side type. So we have a drop-down list and we can assign this line with a new type of side. So what we'll do, we'll select top. So this will now make this part react as a cabinet top, so which means that we'll have the top material and we'll have also the connection assigned to the top part as well. So now if I click return, Often you will have a message that will let you know that the cabinet may lose section in information, which means that in some cases, Cablevision will delete some sections, some parts in order to rebuild the cabinet. So it's not always happening, but it's just a warning to let you know that you might have to redraw the doors or the shelf, for example. So we'll click OK to save the shape. So now my parts are modified. So my top is now with the correct angle. And also, if I have part inside the assembly, they will also be modified. So if I double click on my assembly to go in the section editor, and I go inside the assembly, I will see that if I move the shelf will follow the shape of the cabinet as well. So if it comes to meet the top, I don't have a clear connection between a shelf and the top, so I will just have a butt joint with a miter for now. And if I go back to have my shelf to meet the cabinet hand on the left and on the right, I will have the shelf holes being automatically applied by Cablevision. So this is now my new cabinet shape. And if I check in 3D, I will notice that my doors now also are shaped, my top, my back as well. So this is a very powerful function of the shaping module, where in one tool you can shape an entire assembly with Cablevision. So what we did now, it's really important to remember that this is a shape that we manually created. So if I right click and copy this assembly, and let's pretend I want to resize it, I don't have any specific rules to tell Cablevision how to reshape it. So what will happen if you happen to change the shape of this assembly? Cablevision might decide on its own to modify the angle, modify the height of the right hand, or the width of the top, for example, just because there's no rules to define what's happening if you change the size of your assembly. So with the shape editor, we have an additional tools called constraint. And the constraint will allow you to actually add rules to the shape of an object. So what we could do, we could even, for example, lock the width of the top or lock the angle being applied on the top side of the cabinet, for example. So this is with the constraint tool. So in order to play with the constraint, let's do first a very simple example. So we will now go and practice it on upper cabinet. Let's say we want to create a notch at the back of our cabinet to allow a vent to go through. So to do it, we can simply draw it, of course, and use this for manufacturing. But let's say we want to save this in the catalog and be able to resize it and having this notch to be always be centered and also always being 8-inch wide and 6-inch deep, for example. So let's do it step by step. First, I will delete those two assemblies. I'll go and add a new upper assembly. So now this is a standard upper assembly. So if I go and check in 3D, this is just standard cabinet. So what I will do, I will apply a shape to my assembly first. And once I apply the shape, I will add constraint. So we can also change the shape on an entire assembly from the cabinet level. So if I go in the plan, face, or end view, I also have edit shape button that will allow me to shape my cabinet. Always remember that you can only shape a cabinet in one single view. So if you shape it in the end view, you won't be able to shape it anymore in the plan or in the face view. So right now I'll decide to do it from the plan view. The plan view will be where I will draw the U shape of my cabinet. So I will click on my edit shape button. That will now allow me to use the shaping editor. So now, first thing, I will draw a rectangle just to roughly define the overall shape of my assembly. Because I want to make sure I have only one single outline, so if I click check, you will see that this is not valid yet. So we will fix that with a trim command as before. So I'll trim and remove any extra line just to have a U-shaped assembly. So this is great, but this is not yet in the center of my assembly, and this is not yet the size I want as well. And that's why we will teach cabinet step by step on how to build this, no matter what is the size of this assembly. So now to do that, we will use the constraint tool. So the constraint tool is in your toolbar. So you have logical constraint and you have a dimension constraint. So the dimensions is where you want to lock the size, you want to lock the angle or the radius of a line or an arc, for example. So we'll first always want to apply logical constraint. So we want, for example, to define what is horizontal, what is vertical, what is fixed, what is parallel, or what is perpendicular to something, for example. So always try to start with the logical one, but sometimes it happens that you might lock a few dimensions in your drawing, but I tend to always start with the logical one. So for the logical one, what I want is first to fix my reference point. So on the top left, I have the origin of my cabinet. And what I will do, I will select the fix command and click to lock the origin of my drawing. So what will happen is if I resize my cabinet, Camvision will only resize it from the right hand of the cabinet, and I'm sure that it's not going to shift this side outside or inside my cabinet. So it's kind of a safety net. So I know that it will always resize it in the right direction. The next thing, I like sometimes to kind of clarify with Camvision what is horizontal and what is vertical. So you can do this with x-axis or y-axis constraint. So the x-axis, you will see that it's very small, but you have an x-axis and a y-axis being applied. And also, if you show it on your view, you can see it also at the bottom left of your drawing as well. So the x-axis is what I want to lock first. So I will click on every horizontal lines and have them to always lock to follow the x-axis direction. So what will happen again if I resize my cabinet? Camvision will not start changing the angle of those lines for me. I want to make sure they stay in the same direction. I'll apply the same to the y-axis. So we have 1, 2, 3, and 4 to lock on the y-axis. So often what I do also, I also lock the length and the width of my assembly. So for example, I want to tell Camvision I want this cabinet to follow the width or the depth of my cabinet. So that's why I can switch to the dimension side, and I will select the length dimension. So I want to set the length of this line. And instead of having a fixed value, I want to switch to a text, and the text will allow me to write a formula or an equation to define the length of this line. So what I'll do, I'll type the equation to get the width of the cabinet. So this is called cab.dx. And if I test it, that will read the width of the cabinet. So cab.dx is a shortcut to get the width of the cabinet. Click OK. So it's already 3 inch, so nothing will change, but this is just when I will start changing the dimension of my cabinet. I will do the same thing. So still set the length, but this time of the depth of my geometry. So I will switch instead of a text, instead of a value, I'll switch to a text and type cab.dz is the depth of my assembly. So now with this text, if I click OK, what will happen if I change the depth of my overall cabinet? The geometry also will follow the depth of the assembly. So now we can go back to adding constraint to our U-shape section. So what I want to do first is to tell Camvision that the back on the left and the back on the right should be the same length or equal length. So we have a logical constraint called equal length. So I select equal length, and all I do, I select the first back on the left, click on the second right on the right, and now those two lines are the same length. And if I click select and select again the line, I can see this is 11, 20, 7, 32nd, and same thing for the other one. So this is the same length now. So the width and the depth of the notch is not correct yet, and that's where we could use again the length command in the constraint toolbar, and let's define the width of the opening. So this one I can just type a value, a fixed value of 8, because in my example, it will be always the same. But if you are a little bit more advanced and do some object intelligence and add your own parameters, you can add an option on the left side where you can let the user input the value of the width and the depth of the notch. So we click OK. And this is reminding me, if I just undo this, that I forgot to set this to be following my x-axis. And that's what's happening if we don't do it. So now the logical constraint will make sure that this stays horizontal, and we can reapply the length constraint and go with 8 inches. There you go. So next thing, I'm missing one thing is to define the depth of the notch. So I use the length constraint and just make sure that I will lock it to 6 inch as well. So now we have the depth is 6, the width is 8. This is equal. So this is here, you have the icon showing you that those two lines have an equal constraint. We have also constraint all around our geometry to lock on the X or Y axis. So those appear on the drawing. And we also have length constraint on the depth and the width of the overall assembly now. So it looks like we have everything we need. So we can even check first, just to make sure this is valid, and click return. Again, we might lose some section, especially if we make complex shapes. So I'll click OK. And in this case, I can confirm that I lost some parts. And also, you notice that if you look at your assembly right now, you have an empty hole at the back. So it's great, the shape is there, but I'm missing parts. And the reason why is because if I go back to my plan view in my edit shape or my shape editor, if I select any line that was empty, I can see that I didn't set the type. So on the type, I will select, in this case, I will try to set it as a unfinished 10 on the left, unfinished 10 on the right. And it's normal that sometimes you have to go back and forth and change type until you get exactly what you want. Sometimes it's an end, a back, a top, a bottom, depending on what you are drawing. So here I will set everything to be an unfinished 10 just to see what will happen. Click OK. And so check my drawing. And it's because I have some dado, so I'm using a blind dado construction. So Cabgen is trying to dado those parts. But if, for example, I would select this and to be a back and finish, you'll see that the connection will change as well. So it's really dependent on the part you're selecting, so you get a different connection. So now we have the shape, and maybe let's add some doors too. So I go in my section, select pair door, and now return. So the shape is defined. So how to test it? So to test it, I always do the same thing. I save my project first because you never know. Let's say you resize and the software crash because you didn't properly shape it and constrain it. So it's always safe to save. Then what I do to test it, I simply copy the original assembly and make some modification on the copied cabinet. So I know that if it's not working, I forgot something, I can go fix it on the original one. So what I want to check is to make sure that this is still in the center of my cabinet. This is also resizing all my parts. And I tend to always try in both directions, wider if I could, shrink it, even go in the plan view and also check the depth to make sure that the depth also stays locked at 6 by 8. So in this case, it seems to work pretty well. And we can see that I still have all my part being shaped and constrained with this example here. So if you have your cabinet being shaped and you want to save it, this is very easy. So I can get my original cabinet again. You simply right-click on the assembly, and you will want to select the option to save as. Save as is to create a new copy of this cabinet. Unless you want to override it, you can click save. But let's say we want to create a new assembly in the catalog. I select save as. I will just put an example, sample shaped upper. And in this case, if you want, you can preserve the height or the depth, but this is really not, you have to. It's only if you want to lock it to a specific height or depth. But by just clicking on the OK button to save, Cabvision will preserve this new assembly in your catalog with the shape and with the constraint. So if I go back and find my sample upper, I can see that my shape is still there and my shape is still constrained as well. And if you want, you can still go back in the plan view in the shape editor and you still have access to the shaping tool. What will happen sometimes, Cabvision will leave the constraint where they were first originally created, but you can still double click on them and click and change the sizes if you want to. So once you save it back, you will likely update the position of the constraint, but originally might show it a little bit off your drawing. So if we save this one, all I change is just to make this 10 instead of 8, for example. So you can still reshape something that you started shaping before. So this is kind of the step-by-step on how you will shape an assembly. First, create the shape, add the constraint, test it, and save it if you want in your catalog as well. So with what we did here, we did it on an entire assembly. So we can also do it at the part level. So we'll do a similar example, but this time at the part level. And what we'll try to do is to create a shape part with an arch on it, and where the arch will be shaped and constrained as well. So I want, for example, the height of my arc to always be a specific height. So what tool can use, let's use, for example, a base cabinet for this example. So let's go in the object catalog and add standard base cabinet. Here you go. And I will use, for example, my front toe kick. I want this to be a shaped toe kick. So I will have to double click on my assembly to go in the assembly editor. And in the assembly editor, in the face view, you can now select the front toe. And if you right click, you have a similar tool to the cabinet shaping, but this time it's at the part level. This is also the edit shape button. So if you click on it now, you have access to the full shape editor to make your custom shape with constraint, and you also have access to constraint as well. So in order to do that, we'll create our arc and add constraint on it. So this one, we'll do it step by step, and you will see my way of doing it, but keep in mind, this is not the only way, of course, to shape a similar object. So typically what I do first is I will first select the line I need to shape. I will right click on it, and we have a tool to break an object. So I'll select I want to break in 3 equal segments. Click OK. And now that will allow me to work on each of those segments and shape them and constrain them the way I want. So now I have those. I will now start adding logical constraints. So first I will fix my origin. Next, I will add some X and Y constraints. So this not X, it is Y this time. So just by looking at this axis on the part itself, this is the Y axis. This is Y, and this is Y as well. I don't need to add X, Y axis constraint just because this is going to be an arc, so it's not going to follow any direction, specific direction. So I'll just do those 2 end segments, and also I'll do an X axis constraint on the left and right segment as well. So this is now with fix and also X and Y axis constraint. Next thing I'll do length constraint just for my overall part length. So I want to make sure this part will follow the length of the actual object. So because we are at the part level, so we cannot write what we wrote before, the cap.dx, because if I write cap.dx, it will return the overall width of my cabinet. This is not in value. This will be under text. It will return the overall width of the cabinet, which is not the width of my actual toe kick. So in this case, if we want the length of a part, all we have to type is dy. dimension y, d for dimension y. And if you look at the little axis you have in the corner, y, x, so y is horizontal, x is vertical. So this will be the dimension on the y-axis. And if I test it this time, it's returning 29 because I have half-inch recess on each end. So this is correct. I can click OK. And I'll also add the same length on the other side. And this time will be dx. I can test. And this will be the width of my part. And click OK. So I have dx, dy. Now, let's say, pretend I want this is going to be 4-inch on each end. So I will still use my length constraint, and the value will be 4. So now this endpoint move 4 inches from the left. And if I do the same on the right, select 4, this endpoint also moves. So now if I use my select command, this now is what I need to shape and constraint last. So what I will do, I will first bend to give it the shape I want, but I will not yet set any specific radius. So I just bend my line. And now what I'm missing is a constraint to tell CabVision what is the radius of this part. So for the radius, what I want from my origin, the bottom to the height, this point I want, for example, 2-inch or 2.5, let's say 2.5 inch all the time, no matter what is the size of the part. So that's where I have to go back to school a little bit. And there's a very handy formula to calculate the radius of an arc, sorry. So what you need the width of the base of the arc and the height you want as well. And then you have a formula that you can use. And we'll send you a link to this page where you have the formula, but this is basic math that you can find all online as well. So how to write it in CabVision? So what I will do, I will select on the dimension, the radius constraint, select on my arc, select my arc and click to open the prompt to input the value. So instead of having a fixed radius, I want to input a formula or a text. So the equation, I have it saved in my clipboard. I'll just paste it on the screen. So 2.5 here present the height of the arc, and dy minus 4 represent the width I need, and I need it 2 times. So dy minus 4 times 2. So I just want the internal width of this arc. And if I test it, I will have the correct radius to keep my arc exactly at 2.5 inch high. If I click OK, and I can use my measure tool. I can come here and come somewhere here, and this is exactly 2.5, as you can see. So now the arc is constrained. I can use my check button. So the shape is valid, and I can return, save the new shape. And if I now go in 3D, I can see that my toe kick now is shaped exactly the way I want it. And again, if I would want to test it before saving anything. So I will save the job, copy the cabinet, and change the width, and make sure that I keep my 2.5 on my part. And I can change the width, make it wider, shrink it, and this is still the same height because this is constrained now in my toe kick. So another tool that you have with shaping that would be very handy for this type of shaping is the library paths. So what you created here, it's often that you want to save and reuse it. So of course you can save the assembly itself. So I can right click, save this assembly and reuse it in another job. But you could also, with a tool called a library path, just save the path itself without saving the entire assembly. So how we do that is we go back on our base view, select the part, the front two, and if you right click on it, you have a command to save to library. And now save to library will just save the part with its shape and operations. So now in this case, I just have a shape, so that's what I want to save. So I will select in my catalog place where I want to save it. So I'll call it furniture. So don't forget to check output to CNC if you want to cut it on your CNC. No need to preserve anything because you want this to follow the size, the material, and the finish of the actual assembly that you're going to use in a different job. So I click OK. So now this will be saved in my part library. And now how do you use it moving forward? So what you do is, let's go in the base cabinet library. Let's take a completely different assembly, the base 3 drawer. So what I can do now is I can go in my assembly, select the existing front tool, and when I select it, I right click. I have now a tool to replace the part with a library part. So under replace, you have replace with a library part. And now Camvision will ask you to select the library part you want to use. So this is where I save my furniture tool. I click OK. And now this part now will be now using the shape of the library part I had before. And it will still apply the shape following the constraint of the save part as well. So in one click, you can reuse this shape and now have it applied on your assembly in one click. And of course, if I change the width, this is still constraint, so it will still resize properly as well. So this is part of shaping, the library part. So we use it often to customize shape and save them in the library. And we'll see next that we can also use it for operation. So operation is our next topic. So for operation, with the shaping module, you can add your own custom operation, and those operations could be parametric as well. And also they could be saved in the part library as well. So let's do one example. So let's pick a part. For example, I have an object in my catalog. It's upper and the upper. I have in the column fillers and panel. And this will be, for example, a floating shelf, like this one. And let's say I have this object in my library. It's a mitered following shelf, but the customer wants to add some pucklight hole underneath. So with shaping, what you can do is you can select any part similar to what we do before. So we have the bottom, but this time instead of shaping it, shaping is just to change the overall size. We want to edit the part. And when you edit the part, you want to be in the CAM tab, and the CAM is where you can add your own operation on the part. And in the CAM toolbar, you have a drawing section, and the drawing is basically where you can create any type of operation. You can create a hole, a line boring, dado, or even free shaping, drawing your shapes. So if you wanted a cutout, it's a rectangle. If you wanted a path, it's a polyline, for example, or you can just draw a line and arc as well. So what we'll do, we'll use the hole command. So the hole is what we'll use to just drill, for example, 2 holes for a backlight. So I select the hole command and I just click twice anywhere just to add 2 holes, and I switch to select. And now let's select the first hole we have. So when you select an operation, you can see its properties on the left and you can change them. So you can change the diameter of the hole, you can change the depth of the hole, and also the position of the hole, as well as the tool being used for the machining on your CNC. So let's first change the diameter to 2¼ And let's also change the depth, because right now it's only ½ inch deep. So if I check, this is not going through on my part. So if I want to go through, I go back to my cam view, select my operation again. Under depth, so the rule to make this a through hole is to make the operation exactly the same as the thickness of the part. So in this case, if your part is 3/4, you want to make the operation exactly 3/4. If you work in metric, if your part is 19.05, you want to make the operation exactly 19.05, and that'll create a through hole. And if you do nesting, Capvision will take care of making the operation a little bit deeper to get into your spoil board. This is all be done automatically. You don't make the operation deeper than the part, you just make it exactly the depth or the thickness of the part. So to do that, the best way is when we edit the depth, instead of typing 3/4, because maybe we use 3/4 today or 5/8 tomorrow, we can switch to equation and we can type under the Venn line column DZ. And the code column DZ is a code to get the thickness of a part. So column DZ, I can test it and it will return the value 3/4 because I'm using a 3/4 material. Now, if I click OK, you'll see that you have a little symbol that will tell you that this is now an equation and this is automatically calculated for you. So don't change it manually here. If you wanted to change the equation, just click on the equation symbol again to reopen it. So now if I go in my 3D, now I can see that I have a through hole on my part. So now this through hole is done. I want it to be always centered on the width and the depth of the part. So I want to, for example, have this halfway through the width. So instead of 6" on the x-axis, I can edit the position, and in an equation, I can write the equation to get half of the width of the part. So in this case, this is on the x-axis, so I put dx divided by 2, and in front of the dx, I'll put a column, and the column means to read the value of the parent object. The parent object is the part on where the operation is being created. So if I test it, column dx is the width of the part divided by 2. So I click OK. Now this will be always centered on the depth or the width of the part. And for the Y position, I'll use a code that I like to just to get a third of the length of the part. So this time this is on the dy, so I'll put column dy, and there's a little code. If you put times 3, divide by 3, times 1, I believe, if I'm not mistaken. So column dy divide by 3 times 1, hit all the spaces and test it. And this will return basically a third of the length of the part. And I can do the same thing on the other one. So let's first make this 2¼ Let's make the depth to be column dz. This is the thickness of the part. And let's make the position x column dx divided by 2. This is half of the width of the part. And let's make the length to be 2/3 of the length of the part. So I'll put column dy divided by 3 times 2. So 2/3 of the length of the part. And I can test it. And there should be somewhere around 24". And if I will take my tape, for example, and just measure from here to here, I have about 12". 12". 12". There you go. So this is 1/3, this is 2/3. Can return. And now with my cam editor, what I did, I added my own custom operation, where I also added some intelligence to the operation as well. So now what's happening is if I just copy the same floating shelf and resize it, this will be always spacing out those, maybe a little bit lower, automatically. So this is part also of the shaping tool. So this is adding operation, modifying operation using the CAM editor. So you select your part, click edit, and you have access to the CAM where you can add your own custom operation on a part. And also by selecting an operation, you can modify the properties as well. When you do that, here we just did a hole, but if you do, for example, a different type of operation, let's say I do a rectangle, which would be a cutout. So this is also where you can set other parameters. So you can set the cut side. So if you want to cut in the center, on the left or on the right of the geometry. So if you select left or right, that will change the tool compensation on your part as well. So let's do it on this one. If I reselect it and change the cut to left, I'm cutting inside. If I change the cut to right, I'm cutting outside of my rectangle. Path is, if you want a path, it's just to follow the shape of the geometry. So you will have the tool to go around the rectangle. If you select pocket, is if you want to remove the material inside the rectangle. So when you have pockets, the tool composition is grayed out just because Camvision will only pocket inside the rectangle automatically for you. So you will start in the middle and then clear all the material until you reach the boundary of the geometry you have here. So this is with pocket, and if I switch back to path, I can have, again, my tool conversation. And also you can assign a tool. So assigning a tool will allow you to select a specific tool to do an operation. If you leave it to auto select, so Camvision will try to guess what is the best tool to do it. So if it's a full cut or if it's not a full cut, for example, if you have a material with the side up or down, so that might affect what tool will be used to do this operation here. Another useful tip when you do operation using the shaping tool is when you have an operation selected, if you right click on it, you have the edit button, and the edit button is actually allow you to open the shaping editor just for a single operation, which means that everything we did earlier today to shape an assembly and constrain the shape, you can do it at the operation level. So you could say, I want this to, for example, bend this and apply kind of constraint on the radius of the arc. This is all possible at the operation level too. And this is exactly the same tools, 100% of the same tool we had at the part level and at the cabinet level again here. So if you return and save, your shape will be updated, and now Camvision will create the shape following. So we create the operation following the shape. Okay. So when you put all this together, and that's where you have to just get used to all the tools, that's where you can actually manipulate shapes, constraints, library parts, and CAM editor to add operation to create very customized assembly in your library. So one or two last tool that we have also we can use with shaping, and I'll just move this on the side, is if you have a part that you want to split, you can do it in one click with shaping. So let's say I put a tall assembly with a pair door, and let's say this is, for example, 108. And let's say my cabinet is 108, but I only have 96-inch material. So maybe I know that my back will not fit on my CNC machine, on my material, on my CNC machine. So what you can do is if you edit this assembly, if you select the unfinished back part, which right now is 104, with shaping, you can right click on the part and you have an option to split a part. And this is called editing split. So you can edit the splits and you can add a vertical or horizontal split. So if I create a horizontal split, let's say I want to split behind my fixture, what will happen is Camvision will, instead of cutting one single back that will be 104-inch, it will actually automatically on the CNC split this and cut two separate back. And if I go check my report view, which is also my cut list, I sort by part name, I can see that now I have two bags. Almost the same because I just did it like roughly on the screen, but this is basically two bags that will be created. And the nice thing about it is when you will split it, so on the end user on the drawing, nothing will happen. So you will still show it as a single bag. But on the CNC machine, in the STM center, you will have two parts being created. And what will happen also is if we have operation, let's say this bag as a dado, so the dado will still be created on the end as a single operation. So I'll have a dado that will run from top to bottom. But also, if I split the part, the actual tenon that's going to be created on the unfinished back, if I take this unfinished back part, and I'll have a tenon on the part, which we don't really see here, but this will basically be created on each back that will be created by calibration for me automatically. So I will be able to fit them on the side of the cabinet and still have the tenon to assemble my cabinet. The only thing you're not going to have, and just to keep in mind, is calibration is not going to create the machining. For example, if I take this, it's not going to create the machining to get those two pieces together. So you might to have manually to create a lamello or something just to get those together. But the machining on the side will be created on part A, and it will also be created on part B on both ends for you. You're just missing this little part that calibration will not do automatically for you here. So this is with the shaping tool. So as I said, it's any part, right click, and you have the option edit split to create split on parts for manufacturing. And the last one is a very simple one. It's simply in the 3D view. So it's just when you have shaping, because you will start dealing with more custom and more complicated cabinet, is now you have a tool to explode the view. So when you're in 3D, you can explode, and the exploded view, when created, you can still send it to your drawing, and you can then add them to your drawing as well. So I can take my exploded view and get this printed on my drawing if I want to here. So this is also part of the shaping features as well. So this is overall what shaping does. After that, it's really a matter to combine all those tools together and create some very interesting assembly. So if we go, for example, here, this is the kind of thing you can do, and shaping is the tool to do those kind of assemblies. And if you don't have shaping, that will be not impossible, but very, very, very much complicated than using shaping. And in this case, there's a combination of library parts. So for example, you already create those partitions, save them as a library part. Then you can shape your assembly using the shaping editor. And if needed, after that, you can also add your very own custom operation everywhere you need using the CAM editor as well. So just quickly to give you kind of like an idea of the workflow, is you will have an assembly, for example, that you will call a die wall. If I take the example, my base here, I have maybe a die wall object. It might just be empty, but it's just an assembly where I remove all the parts, kept the side, the top, put a full top, remove the back, and just leave it open. And then what I do is I would, for example, stretch it. I might, and just to show you quickly, I might even shape it with radius. So I can go here, bend it a little bit. It's not very accurate, but just on the screen to give you an idea. And then I can say I want to add a couple of, in the interior, couple of splits, 3, 4, depending how many I need. And then what I will have is in my library part, I will already have basically a partition with the machining I need. Let's say I need a wire chase. I will go in partition, right click, replace, and maybe in my library I have a partition with wire chase, for example, here. And now I can see that I can recall my machining, get my machining back on the part automatically. And this one is kind of the same as we did on the backlight example, where the holes will always be spaced out evenly on the part. And of course, you can even add shapes or other operation on the part as well here. So this is really essential if you want to start creating those type of assembly using shaping. This is the workflow to do it. After that, you can input more automation, not part of this training today, but with UCS, you can write code to automatically have it being replaced in one click, or make a selection on the side menu, for example, as well. But this, you need the foundation of the shaping and the constraint first and the library part to start making those more complicated assembly that you see on the screen here. So this is what we wanted to cover today. So I will get back to you, Amanda, and we'll see if you have any question in the chat.
Beautiful. Thank you so much, Christopher. So much fun to watch you doing that. You make it look so easy. So everyone who's on the call, I invite you to type in some questions either in the chat or in the Q&A. We don't have any for now, but we did hold a webinar in French earlier today. So maybe we can bring back some of the questions that people had asked this morning. So one of the questions was that one of our users had trouble adding constraints sometimes to parts or assemblies when there were already a lot of constraints that had been added to it. So they wanted to know, is there a certain order in which I should add constraints?
Yes, very good point. So when you start adding a lot of constraint, and I can show you an example of a part I created. This is starting to be very busy, but let's find a little place on the screen. So a valence, it could be a valence or a toe kick, but just a part where I have a lot of radius and different part of the drawing I had to constrain. So if I just edit this part and go in my face view, select the part and click edit shape, you'll see that this one, I can't even count how many constraints you have. But if you see that there's so many constraints where you're having trouble, it's starting overlapping, keep in mind that you can select any constraint that you add and you, after that, can move it freely around the geometry. So it's not because you put it on a line that it has to stay here. It will still be attached to this segment, but you can move it. So just it's not in the way, you can reselect it and get to the geometry you want on the drawing here. Once it's created, after that, it will just disappear, but you can reorganize those on the screen if needed, and then you can still use your part freely if you need to.
Awesome. Thank you so much. So I see we have someone trying to raise their hand. Lara, if you are able to, please type your question into the chat because I'm not able to access your microphone so we can hear your question. We can always try to follow up afterward by email if you're not able to type right now. Another question we received this morning, Christopher, that maybe we could review now is, are we able to change the shape of multiple assemblies at once?
Yes, so you cannot shape multiple assembly at once, but you will want, if you need to do that, to do it from the plan elevation view, so at the room level. So you can already draw a sketch of it using the CAD tool, or even better, import a CAD file that actually show you the shape of the final layout you're trying to create. But then you'll have to go individually on each assembly and then shape them one at a time. A perfect example, if I had those three cabinets together and they all had to have some sort of angle, let's say I needed an angle on the left and an angle on the right and maybe a radius at the top. So I will have to click on the first assembly, edit the shape from here, say I lower this a little bit, then save, then go to my other assembly, shape it, but at least I can see the entire wall elevation and make the change without having to go back and forth inside and outside cabinets. So if I say, again, I can still shape this, and this one, maybe I want to, maybe not going to end well, but let's create a radius. And now it's going to be shaped. So the only thing, you just want to make sure the elevation till 54. And then you have all those three that look like they were shaped together, but they indeed been shaped separately.
Perfect. Thank you. Another question that we received is, can you change the shape of a whole drawer at one time?
It is possible, but drawer is not an assembly on itself. So you'll have the hardware will be to go select each part, and each part will have to be modified individually. So you'll have to select, for example, the back, you'll have to select the bottom, cut out the bottom, and add maybe additional part. So you will still use the tool that we explained today with shaping, but you will not have it done in one click where you can do it in an assembly. If you have to do it often, I recommend you to reach out to our tech team. We have some solutions, some packages for shaping drawers to create U-shaped drawers. And what will happen is you can basically create a package where you have an option on the left side to shape a drawer. You select yes, and then you can select the width, the depth of the notch you want to create, and it will automatically shape and modify all the parts for you at once.
Beautiful. Thanks so much.
And thank you for your time today.